Welcome to section 8.2/8.3 video that kind of fills in a little gap between the two of them. Have you ever gone around town and seen some phone numbers like this? 1-800-MIKE-WINS, 1-800-CALL-SAM, and of course, the ever important 1-800-DNA type. Why do these numbers work? Why do you see these numbers all around town? In fact, why shouldn't I come up with my own number, 1-800-SOS-MATH? Yay, pretty cool, huh? Then I could charge people $3 a minute and solve their math problems, maybe charge a premium towards exam time. Nah, that'd be gouging. In any case, why do you have these numbers? Why do they work? Probably because they're easier to remember than what you'd have to dial if you're remembering just the actual number. So let's take a look at this. What I have here is a couple sets of ordered pairs. I called one group of these ordered pairs a phone function, one of them called a phone relation. But this first one is good for our purposes, because what we can do is we can take a number like SOS math and figure out, well, what would you dial? So let's come down here to the S. Oh, that's paired up with the 7. And you can see these things on your phone. Just open up your phone, take a look at the numbers, and you'll see all these things. So S goes with 7. Okay. And then O goes with 6, etc. And you can fill this out. Turns out you dial 767-6284. So there you go. Kind of nice. But these numbers work because it's easy to remember. I'd never remember 767-6284 unless I spent a little time and effort on it. But SOS math, that's pretty easy. So what's the tie into what we're doing here? Well, before I explain that, let me work on this one. Suppose that being a conscientious math instructor, I want you to have a nice phone number to call and get some help. So let me give up my supplemental instructor and have you call her cell phone. So, all right, I'm kidding. I wouldn't do that. But maybe I want you to be able to ring my office number, and my office phone number ends in 2678. So we're going to kind of do the reverse. Last time we had the letters, we wanted the numbers. This time we have the numbers, we want the letters. So what letters go with 2678? Well, let's flip back to our little handout. And let's see, 2. Well, there's a 2, goes with an A. Oh, but wait a minute. 2 also goes with B. And oh, this is even worse. 2 goes with C. So there's a lot of choices. And the bottom line is that you really don't have one unique choice. You've got 3 different choices. And that's kind of a problem mathematically. We don't like that. Now you might notice that the difference between the phone function and the phone relation is simply the order in which I wrote these ordered pairs. Every little element in this set here, like A, 2, that's an ordered pair. 2, A is an ordered pair. But somehow or another, in interchanging the X and Y coordinates, I've created a problem. What worked nice for our phone function, that is, I gave you the letter, you give me the number, doesn't work so good for the phone relation. So we got to explore this relationship a little bit more. Now, I've used the term relation several times, and a relation is just any set of ordered pairs. So both of these sets of ordered pairs up here, the phone function and the phone relation, both of those are relations. Now, you might place a bet on the fact that there's something a little bit more special about the phone function that makes it a function as opposed to just a relation, which is what this is. In working with relations and functions, I need to come up with some more definitions here. So let's talk about the domain. The domain is the set of X coordinates of a relation. So let's look into the domain a little bit, and we'll do that for our phone function. The domain is just going to be all the x coordinates for that set of ordered pairs. So the A, the B, the C, all the way down to X, Y, and Z. Those are all parts of the domain. I didn't underline all of them, but they are all part of the domain. So let's look at that over here. So for the phone function, we've got a domain, which is this set. And I use the curly brace to denote a set. It's a set of A, B, C, all the way down to X, Y, and Z. So that's our domain. Now, of course, that leaves the Y coordinates out in the cold, but we've got something for those as well. And the Y coordinates of a set of a relation are the range. So let's take a look back and figure out what the range is going to be. The range is all the Y coordinates. So a 2, well, another 2, and yet another 2, and a 3, and they go all the way up to 9. So basically it's the numbers 2 through 9 would be your range here. So the range is 2, 3, 4, 5, 6, 7, 8, and 9. And notice you don't have to list things more than once. I know that there were several ordered pairs that had the 2 and the 3, et cetera, in it, but you only have to list it once. So there you go. Now, flip things around a little bit. Take a look at the phone relation and see if you can't figure out what the domain and range are for each of these. So if you want, pause the video for a second, see what you can come up with, and then compare answers with me. Did you come up with something like this? I hope so. Basically, all that happened is that the domain and range interchange between one and the next. So now that we have a little bit more vocabulary, let's try and understand what makes the phone function so special. What makes something a function? And I've got 3 different definitions for you of what it means to be a function. So those are right here. Pick whichever one makes you feel most comfortable. A function is a relation in which no 2 ordered pairs have the same first coordinate and different second coordinates. Well, this one fails pretty quickly right here, our phone function. It's got the same first coordinate, but different second coordinates. So that one's not a function. But we're okay here. You can have, in fact, all of these are different first coordinates, so you're not going to have this problem with the phone function. How about a function is a relation in which each unique first coordinate has a unique second coordinate. So for every unique first coordinate, I should have a unique second coordinate. Again, it fails right away because 2, that x coordinate, has different y coordinates. Last but not least, a function is a relation in which each x corresponds to exactly 1 y. Well, A corresponds to exactly 2. B happens to correspond to exactly 2 as well, but that's okay. B corresponds to exactly 1 value of the y, or y coordinate. Same with C, D, it's in fact all of these. Whereas here, with our phone relation, you have 1 x coordinate corresponding with different y coordinates. So one way or another, you've got to get used to the fact that if I give you an input, you can tell me exactly what the output is. If I give you the x coordinate, you know exactly what the y coordinate is. So that's kind of like a 4th definition of what it means to be a function. Now let's practice that with a couple examples down here. So this first one right here gives you this set of ordered pairs, 2, 4, 4, 3, 3, 5, and 5, 1. And for your convenience, I've plotted them right here. And we'll take a look back at the plots in just a little bit and try and get a little bit more out of this. We'll start with a couple simple questions, beginning with what's the domain? Well, the domain for this one is just going to be all the x coordinates. So that would be 2, 4, 3, and 5. Now, it doesn't matter exactly the order that you write them in, but I'm going to write them in increasing order. So the domain for that one is 2, 3, 4, and 5. Domain 2, 3, 4, and 5. What about the range? See if you can't beat me to the range. Range, of course, is the y coordinates. So let's highlight those. Four, 3, 5, and 1. Now, you don't have to write them in increasing order. I took the time to do that. That's okay if you didn't. But that's your range, is the y coordinates. Now, the big question that we got to work with is whether or not this defines a function. And so you got to ask yourself, if I told you what the x coordinate is from these values, could you tell me exactly what the y coordinate is? If I said x is 2, would you know that y is 4? Yeah. If I said, what happens when x is 3? Well, you look at this pair here, and you know that y is 5. So yeah, if I give you the input, you know exactly what the output is. So is it a function? Yes. And that's supposed to be a check mark, but it's not. Sorry. Ah, that's looking even worse. Okay, there you go. Never happened. Let's move on to the next one. And that'd be over here. So this example, I'm going to do the same thing over here that we did with the previous one. That is, decide the domain and range, and then ask ourselves whether or not we think this is a function. So here we go. These are the points that should be in domain. So that would be 1, 2, and 4. If you notice, I didn't list 2 twice. It's enough just to list it once. How about the range? Maybe you're ahead of me on that one. Here, 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 and here. So for the range, oops, forgot to change the style. So for the range, that would be 3, 4, and 5. Nice. Now, is it a function? If I gave you an input, would you know exactly what the output is? The first one was yes over here. But did you say no on this one? I hope so, because it's not. There is a problem. Can you see what the problem is? Problem is right here and here. You've got the same input with different outputs. So those 2 points are here and here. And that's kind of a bummer that we don't have a function here. But the nice thing about this graph is that it gives you a good visual way to decide if something is not a function. And that visual means of deciding whether or not something's a function is called the vertical line test. So what on earth is the vertical line test? Well, it's actually defined for you, written for you down here at the bottom, A vertical line test. So this means a graph represents a function if any vertical line intersects the graph at most once. Well, when we look at the graph to the left, vertical lines, any vertical line that you can draw intersects the graph at most once. So some of them, in fact, most of your vertical lines aren't going to intersect at all, but they can intersect at most once. In the second example, this vertical line touches the graph twice, so it fails the vertical line test. And that's a big thing. That tells you that something is not a function. And it's a nice visual way to decide whether or not, hey, this is a function or it's not. Now, while you're at home doing these kinds of problems, you may or may not have a graphing calculator. So let's practice a couple problems that you're going to see in your homework using something that's available to everybody, which is the internet. We're going to decide whether or not a few functions are, a few graphs are indeed functions by going to a website called Desmos. So here we go. And let me just start from scratch. Let's take a look at a few graphs, starting with y equals the absolute value of x. Now, you may not know what this looks like. Maybe you do. If you do, great. If you don't, that's fine too. You should be able to find a vertical bar for your graphs, or just give me the input into things. For myself, on my keyboard, let's see if I can, yeah. It's this one right here. I have to hit the shift key to get there. That's my vertical bar. There we go. Now it looks vertical. If you don't have that or can't find it, that's okay. Desmos provides you a way to input that kind of stuff. So let me flip back over to here. You simply toggle this little keyboard, and there's your absolute value, type in the x, and you've got the graph of the absolute value of x. So what do you think? Is that a function? Does it pass the vertical line test? I think so. Let's test it out. Let's see, how about x equals a? B? No, this isn't working. What I had hoped to do was come up with a nice vertical line, but let me just graph one vertical line here. X equal 1. You can see that our vertical lines intersect the graph at most once. 2, 3, 4, etc. So this passes the vertical line test. Now there's a few other ones in your homework as well. It might be a little bit more messy. One of them, for instance, I think I asked you about the graph of g of x equals negative x squared. So, wow, what's that? Well, let me show you first, which will be asked to graph. G of x equals negative x squared. Now, just in case you're curious, this could be replaced by y equals negative x squared. And you might remember this one, the graph of x squared is a parabola, which faces up. And what do you think that negative is going to do to it? Is it going to make it open down, left, right, etc.? Well, the good news is that we can rely on Desmos to show us what the graph is or remind us what the graph is like. So I'll just type in g of x with the parentheses equals the negative of x. And then you can either hit the shift key and then the 6 key to get something up in the exponents, or from the keypad, type in a square like that. Again, we have to decide, does this pass the vertical line test? So take a look at different vertical lines. X equal 1. Okay, yeah, x equal 2. X equal -1. X equals -2. All right, so all the vertical lines you could draw through here pass through this graph at most once. In fact, exactly once. So this does pass the vertical line test. Great. Let's try some other ones. Now, kind of close your eyes, don't look at the function, just look at the graph, because the function is not something that we've covered yet, but it's kind of cool. How about that one? Does this graph pass the vertical line test? Well, let's look at x equals, say, 0.5. Looks like a lot of points of intersection between our two graphs, right? Let's hit the projector mode up here. So hit the toolbar icon, click projector mode. And I think it's pretty clear that this graph crosses at more than one place. And it doesn't matter where, it just matters that it touches the graph at more than one place. So this is not a function. All right, like I said, don't worry about that until you get to trig. There is one more that you will see in the homework, or something similar to that. Let me share that one with you. And it's y squared equals 3x plus 4. Numbers actually are a little bit different, but you've got the y squared in there. So once again, type in a y. You can either use the keyboard to hit the square button, or you can hit Shift-6 and then type in a 2. Let me do that, Shift-6, and then I'll type in the 2. Right arrow to get out of the exponent equals 3x plus 4. Okay, so a sideways facing parabola. We'll learn more about these later in the course. But for now, is this a function? And I hope you give a big fat no as an answer, because it fails the vertical line test. No. Fails the VLT. In fact, that's how I want you to answer the questions when I ask you directly, why is this not a function? You can just simply say, hey, fails the vertical line test. That's perfect. So keep that in the back of your head and you'll do well. All right. Hope that does it for you. Good luck with this section.